Hello everyone. Let's solve the question is 35 38 module operation for minimum travel time, and it's a quite long question. So we have two arrays, basically the positions and time, and let's go through the example first because that's easier. You're traveling by car basically, and then so let's say to travel from 0 to 3, you take the time 5, which is, I guess, um, yeah, travel 1 kilometers between position one. So this is that represent the time in minutes required to travel 1 kilometers. So because we have 3 kilometers here, the time for 1 kilometer is 5. So in total, you're going to take 15 minutes. And next is like 3 to 8, and then you can travel with this time 8, and because it has the 5 kilometers, that's going to be 40 minutes in total, and so on. But we also have different parameters like this, and what is this? So O is kilometers in total. So I don't think it does matter because we already have that information here, position, like 0 to 10, that's 10 kilometers. So you don't actually need this information. And n equal 4 is also not necessarily information because I guess it is just the length of position, right? Yes. So yeah, the length of n, so it doesn't matter. You can easily extract this end by taking the length of this position or time. So you don't really care about these two parameters actually. But there's one more important parameters here. So k equal 1. So what is this k? So in this number, you can merge some positions in time, basically. So let's say you're going to merge like this 3 and 8. So that means you remove these threes, and now so now the position is 0, 8, and 10. And when it comes to the time, so from 0 to 8, you still use this 5 as um, a traveling time, I guess, right? Yes. So you're going to use this, but in the next step, so from 8 to 10, the time is also going to be merged. So this 8 plus 1, no, 8 plus 3 is 11, and that is going to the time to travel from 8 to 10. Okay, and then your job is to find the minimum total travel time in the minutes from 0 to L. And after K, exactly K merge. So you have to consume this K, um, like all of them, like K times. So that's the question. And you might think of this as a DP question. This is actually a DP question, but one of the difficulty here is this merge operation, right? So as soon as you've seen this question, you might want to cache. Yeah, let's think of like top-down approach first, like with memoization. So like when you have like these kind of the list, obviously it is not efficient to store the list as a key of memorization. So you don't want to do that. So easy approach is use index. So probably like I and J, you can have that parameters, and or maybe just only I, and then kind of try to minimize it and minimize and then like define a base case and then define a merge case and then solve the problem. And but you cannot easily do that in this question. So what is the hardest part of this question is the margin. So so you are allowed to do k operations to merge the positions and times. So what does it mean? So when you merge these lists, obviously the lengths of the positions and time can be different. So like if you merge this 3 to 8, now is like the position looks like this and time looks like this. So if you have just I and j pointers, you cannot, this j pointer, I pointer is not useful anymore because literally the length of array is changing. So that's not going to work. So, and here's where the range DB comes in. And there are different types of range DB. And actually, if you use just I and J pointer, it can be just called range DB. But I'm going to introduce you a specific use case of the range DB with a for loop inside of DB function. So the idea is that because you cannot like you know keep index correctly like while you are doing the DP besides margin, right? So the thing is, you are going to merge the only, I don't know. So let's go through this function actually. So we have I. So this is only one index. No, we don't have like I and J 2 pointers. We only have I and K. You don't have to worry about speed yet. So, and then this is a base case, and memorization case. So I'm going to skip that. So here's the juicy part. So what I'm doing here, so I'm going to start from obviously zero. I is initial value is zero. So this J for loop, so it's going to one to n, and I'm going to go through J, and then can you see like I'm merging now? I'm merging um in the current recursion. So what I'm doing here is I'm trying to merge J and I, and so let's say so 0 to 3. I mean, you don't really have to merge it because um so I'm traveling this 0 and 3 with this five speeds, and because I'm going through until n, that is going to be now 0 to 8. So what I'm doing here actually is you merge 3 and 8, and I'm thinking this as 0 to 8. So that's what I'm doing here. But important thing, you don't change the time when it comes to this first recursion, because no matter what, how many times you merge, it's still going to be the speed is 5. So I'm going to use this speeds. I'll talk about how we can populate this later, but we're going to use that as the current total time and then pass it. So pass J in the next param in the next I actually. So why this is so significant is because so let's say you merge this 0, 3 to 8, and now it doesn't matter like this portion is merged or not for like these cases 8 to 10, because this is already merged, and you do calculate the total time for this travel for this much travel and before in the previous recursion. So when you add from 8 to 10, or like in the next iteration, next recursion at 8, you don't really care like how these two, like the previous position handles and what is the time. So you can still use the pointers. You're at 8 now. But the important thing, as I mentioned at the beginning, the only thing that is going to affect the later recursion is the speed. So I'm going to have a speed as also a parameter. So I'm actually accumulating this next, yeah, something called next speeds with this like times J. So let's go through the example. So we are at 5. So at the index 0, we are at 5. So we don't really care about it. So J is going to 1 to n minus 1 actually. And depending on how many times you merge, I'm going to create some sort of like prefix of the speeds. So now, if you don't merge at all, obviously the time is 8. But if you merge this much, as I said, like this is going to be 11. And if you merge until the end, that's going to be how much? 17. So that's how I like populate the next piece for the next iteration and then pass it to um, here in the DP function. So this is very important intuition because you cannot handle like, you know, a merge populate only using I and J pointers. You use a for loop to merge, like expand your position, I mean margin as much as possible, and then just get the, unaffected values from the later recursion so that you don't really have to care about like the margin, like the margin operation breaks the list and indexes and everything. You preserve all the indexes and I don't know, consistency of the list later, like in the DP function. And then you kind of break it. You kind of try to merge it in the current recursion. So this is great way to solve like this type of list question. And it's actually a hard question, but once you understand this methodology, it's quite easy and useful. So let me go through this example from the beginning to the end. So yeah, in the initial step, I just keep some variables as instance variables and define this memo. And I'm just calling this DP functions. So the first base case. So when you reach at the end, I is at the end. If the k is equals 0, you return 0 because that means you consumed all the k, right? And then when you at the last position, obviously there's no many there's no more to travel. So obviously um the minimum travel time is 0. But otherwise, so which means the k is not equal to 0, that doesn't meets the requirements using all k. So I'm just returning like the max values of float. And here's the interesting step. So I'm going to initialize this minicast as default inf as well. And then every time I merge in here, I'm for looping from I plus 1 to n minus 1s. And every time I calculate the distance and accumulate the next speeds and calculate the cost and compare the cost with the minimum cost and k minus 1 so that keep tracks of this how many times you merge and then that is also going to be passed to the next recursion DP function. And then finally, because we want to cache it, we are going to um, make it back to the original K and then cache it and return. So it's really simple. Let me run this code. It should be pretty efficient. Yeah. So this is the great example, but let me show you another example here. This is a medium question, but it's also the great example. Okay. So here's another one. So you're given the nums and integer k, and then your task is to um, so partition this nums into k subarrays, and then you take all of the numbers in the subarray with XORs, and then return the minimum possible values of maximum XOR. So basically, so k is equal to here, so you split into 2, and then you have this XOR, then this XOR, and so this is not great example. Let me show this one. So k equals 3, you split 3, so you get the 2, 0, 2, here. And so the maximum, so you take the maximum value from 2, 0, 2. So 2 is the answer, but you want to minimize this numbers in iteration. So depending on how you split, although you take the maximum out of these three, the partitions, but you want to actually minimize it. So this is also a range GP question. And how you handle it is, so you take, so basically you keep expanding this partition, the first sub, right? So the first is 2, and next is 2, 3, and next is 2, 3, 3. It's easy to calculate, like, kind of the prefix again. Prefix XOR. What is the XOR of these two? Obviously, it's only one number, so it's 2 and 2, 3 and 2, 3, 3. It's super easy to calculate this. And after that, you are going to get the max numbers of this DP, right? So J plus 1. So after kind of the margin partitioning, you take the later index J plus 1s and K minus 1s, and then get the maximum values and assign the minimum values, and then just return the minimum values. So this is really similar to the previous question. So basically you have the pointers as a parameter, and then you kind of merging it, expanding it using for loops, and you do expand operation nows, and then pass the next index that you want to expand. So that is not the part of um, partitioning or like expanding now. So from J plus 1, you can expand another, like, the partition. So that's how you handle it. Okay. So yeah, before my video gets too long, I'm going to finish here. I hope you learned something from this videos, and I'll see you next time. See you.